the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
A friend of mine, Stephen Eggett. Today's seminar is sponsored by the joint sponsor of the seminar series, which is WSP. So Steve is a vice president of WSP, and there he leads the operations of the downstate New York Earth and Environmental business line. So he has almost 30 years of experience in environmental engineering, sustainability, permitting, and compliance. Steve specializes in providing these services to government agencies in the metropolitan New York area and was the environmental engineer of record on some of the largest infrastructure projects in New York City, such as the LaGuardia Airport Terminal B expansion, which is really a beautiful thing now. Second Avenue Extension Phase 2, and the Port Authority Bus Terminal replacement. Steve got his BE in engineering from Rutgers and his ME in environmental engineering from our department at Stevens. He's a professional engineer in multiple states. Today, Steve is going to talk about decarbonizing public infrastructure projects. Welcome, Steve.
Thanks a lot, Dibs. I really appreciate the opportunity to speak to everybody today. Again, my name's Steve Eggett. And really this presentation came about, let's switch over here. So just get going here. So the presentation came about for me in January timeframe. I'm a member of Transportation Research Board, one of the committees there, and the talk at the annual conference was all about decarbonization. That's probably was every presentation there. We talked about decarbonization, either decarbonization, sustainability, or resiliency. So it was a big topic there. And right around that time frame, there's also, I know MTA held a big conference on how they were looking at like decarbonizing their infrastructure projects because of the New York State requirements. And again, another kind of overlap happened when I was hearing a talk, like a debrief from the recent COP that was held overseas from the UN. And they also talked about decarbonizing infrastructure and buildings, and that was a real focus area. So kind of all these things overlaid and kind of wanted me to sort of reach, kind of like look into this topic and research it a lot further, and then, kind of make this presentation for you here tonight. So what we're going to talk about is something I think that's, not thought of a lot, is the greenhouse gas emissions from building and other infrastructure projects. We're going to dig into that a little bit just to let you know, give you a little bit of a background on that. Understanding this concept of embodied carbon, what that means for building enough infrastructure projects, and what people are doing to address that. Low carbon construction materials, what that means and where that's going, and then some of this embodied carbon reduction policies and guidelines that are out there. So, and just a little bit about myself too. There's a recent picture of me at Stevens. So I'm an alumni and definitely try to give back wherever time allows. So professional engineer, you can see some of the other items there. Over 25 years of his experience as a consultant. And in addition to some of the work that was in my bio, really did have been working on New York City infrastructure projects for a long time, as well as New Jersey Transit, LA Metro, and some other private entities as well. So enough about me, right? We want to talk about decarbonizing infrastructure. So this slide here talks a little bit about, the sort of overall emissions global GHG emissions and where construction and operations fit into that. Um, whatever source of information you go to, the number is slightly different. This is a McKinsey number that I got from an MTA presentation. If you look at the UN numbers, the percentage is a little higher, but it kind of gives you kind of an idea of the magnitude that construction and operations of buildings and infrastructure play in the overall greenhouse gas picture. So, it's a big chunk, 25%. Again, some information sources had it as high as 33%. So that's something you can see why there's a focus on this now and why we're looking to minimize those emissions where we can. So of those, that 25%, we can further, segment that a little bit to the construction and then overall operations of it. So it's probably, more than you thought the actual construction goes into the greenhouse gas, emissions of infrastructure. So this gives you just kind of a typical building, typical infrastructure, what that kind of the carbon budget would look like for that, or the how the emissions would play out. There's a lot upfront, obviously. There's a lot of activity due to, the construction, and then you get operations, and then in this scenario here, which I thought it was good to include, is just the, from renovations or like demolition of the structure. There's a lot of activity around that, so the emissions would spike in those scenarios. But over time, as the grid gets a little cleaner, people get a little bit more efficient with their operations, kind of like that operational portfolio goes down. So there's a big kind of push up front during the construction, and these other periods in 15 and 30 years here. So whatever we can do to minimize all those different areas is going to minimize it overall, 25% that we're talking about here today. So it gives you kind of an idea of a typical carbon, emissions profile for a project. So sorry, I went the wrong way. So these are the components of the construction greenhouse gas emissions. So we have the materials. So when we're talking about materials, it's not like the carbon is like stored in there. It's that's all the greenhouse gas emissions that go into the actual production and transportation, which is kind of an important item there too, of the construction materials, the concrete, the steel, the glass, the asphalt that go into your typical project. Then the construction equipment itself, so, and the techniques, because not only the equipment, you think about the big, yellow iron equipment that are out on a construction site, but the actual, a lot of times there's electric equipment or welding. So it's whether you're using the grid to power that or emergency generators, that all goes into your emissions profile. The waste and how you deal with it, because not 100% of what you bring to the construction site is used. So how you deal with that and how you deal with the if there was a existing structure, like if you're building like any typical New York City project, there's something there and you have to demolish it. So what do you do with the construction waste? So all that again goes into your mission profile. And last but not least is the design standards that you're using. Um, is how those affect the operational emissions. So it's something to think about. Um, there's usually minimum standards that every project, like LEED Silver, is a example for building. But on infrastructure side, are you using any design standards that would minimize any of these construction greenhouse gas emissions that we're talking about? Let's give a little example just to show a little bit of order of magnitude from MTA. So you see the concrete that they use, 445,000 tons. So that would equal, quite a bit of, give the equivalent here of gasoline powered vehicles. So it's basically like taking, like 6,500 cars on the road is the equivalent of the greenhouse gas emissions of all the concrete that MTA uses in just 1 year. Um, and you can also see the construction waste that's generated from the projects, 123,000 tons, quite a bit. But you can also see that a lot of it's recycled. So look at how much of that is being diverted from the stream from the waste stream, by MTA. And even the incremental amount that they're over to 7.5%, that goes a long way to reducing, greenhouse gas emissions from these just going to a landfill actually and diverts new materials being required to be manufactured. So it gives you an idea of the magnitude of the issue we're talking about. So now that you kind of have an idea of a typical buildings and infrastructure project, I wanted to discuss this concept of embodied carbon. So that's a concept that talks about the greenhouse gas emissions used like upstage when you're developing a project, all the emissions that go into concrete, all the emissions that go into steel, and all the transportation of all those products to the construction site. So that represents the embodied carbon of an infrastructure or a building represents all of those emissions that went into like the construction and potentially the demolition of that structure. You have to account for all of that when you're developing a greenhouse gas profile of your project. So it's a little bit, it's, sometimes I think people think it's like actually stored in the concrete. And that's not necessarily the case. And we can maybe talk about that in a little bit. But what happens is all the emissions actually go into manufacturing and transporting all those projects or the products to a site. So going into a little bit of detail, you can see all the additional elements that like the embodied carbon portion of a project go in versus operations. So the supply and manufacturing of it, we have little trucks there to show the travel. Then the actual installation of that material. Again, all of that represents the embodied carbon of a material. You have your operations. Again, if you know something was going to be needed maintenance and repair, such as like say painting or additional welding, like that all goes again into the embodied carbon. And then when you're done with a project, how do you deconstruct it or demolish it? How is that waste going to be disposed of? For instance, steel. One of the most valuable commodities on a site is the steel. We'll see sometimes people bidding on projects where they just the price of the steel alone is probably kind of underwrites the project a lot of times. We've seen people bid like a million, like $1 million to demolish a building, and they pay for that with the steel that's recycled. So again, some of these products are very valuable, and there's a big market for them. Others is we're gonna, working to develop more of a robust market for recycling of construction materials. And again, when we talk about embodied carbon, one of the ways to develop that is going through a whole, this life cycle assessment of an actual product to determine what that embodied carbon is. So you have the embodied carbon and then the life cycle assessments used by the manufacturers to determine the actual embodied carbon of a material throughout that whole product life cycle that we talked about. So right here, that's the whole life cycle. So that's the, just this process of getting all the greenhouse gas emissions and all the different phases for a material. Um, there's an ISO standard that actually goes into all of the details of this and all the associated phases. So this gives you just a little bit more detail. It's not just the nice the nice picture here. Um, there's all the different phases of use and all the different items associated with that stage. So this life cycle assessment goes into and calculates potential carbon emissions for all those different scenarios there. So you can see it can get very detailed as you're going through it. Um, so with that, when a manufacturer goes through and does a life cycle assessment for a different product, they come up with what they call a product declaration. So this is one here um, that I use, and it's this cradle to grave kind of scope, and they come up with the actual greenhouse gas emissions for a unit of the product. So this right here is a meter cubed of concrete. So then once you have that, you determine the actual amount of concrete you're using on site, and then you can come up with the embodied carbon for all the concrete that's used on site.
એટલે clearance તમને કીધું.
Yeah, see, I'm sorry, I'm on my laptop. I can't see questions. So if anyone has a question, is there a question?
I don't see any,
Okay,
but
okay.
typically they will ask you questions at the end of uh, the seminar. I think somebody left their microphones on.
Oh, okay, okay. No worries. No worries. So we have this concept of embodied carbon, and then really this is something, these environmental product declarations. For those of you working on infrastructure projects, this is going to be this is this is currently a requirement on many larger projects going forward. So not only are you going to have to, look at the structural integrity of the concrete, but you're going to have to go and actually look at all the environmental, product declarations, and determine the embodied carbon of a project. Some projects right now, what they're looking for is just to have these declarations out. But then there's other clients, other programs where they're looking to really use like lower carbon materials. So again, this is typically, something that would be, is the kind of the virtue of like a structural engineer. And now you're going to see us working more with, all the different disciplines on the project to review construction materials. So I want to do a little bit and just talk a little bit in this section about all the different construction materials and why people, kind of care about that. So first one is concrete. And your traditional manufacturing, it's 7% of global greenhouse gas emissions. So again, it's a big part of our global emissions. So it's important to, look at that 7% and find out ways of reducing it. And also, if we're talking about embodied carbon for a building and infrastructure project, depending on the type of structure, it's 50 to 85% of that. So that's a large portion of the embodied carbon goes into the manufacturing and transportation and setting of the concrete. So what a lot of s- concrete manufacturers are looking at lower carbon alternatives, and there's like a portfolio of ways that they're looking at that. One is the actual manufacturing of concrete. Can they use lower carbon fuels or improve the cement kiln, the efficiency of the concrete? So that's one way of working to lower the footprint of it, is by just making, lower carbon fuels, say going from like oil or coal, which is hard to believe people use coal, but they do. So going from that to natural gas, maybe even try to make it electric, biofuels, but improving the kiln efficiency, so you're using less fuel in the manufacturing. So that's one way to do it. And then also looking at the actual mix of concrete that you're using. Is there a way that you can look at all the different mixes and find out which actually has like a lower carbon footprint? So people are doing that right now, um, and looking at all the different mixes and finding what they're in, like the embodied carbon for all those different mixes, and working to make sure that they not only you know, has lower carbon, but it also has all the structural properties that we're looking for in the concrete. So that's ongoing research that's going there. And then also using recycled concrete aggregate where they can. So obviously, if you're not, you're not remanufacturing it more or finding it more local sources, that's other ways of also lowering the embodied concrete, carbon of the concrete. The last and kind of, I think, the most cutting edge type here is actually using the concrete for carbon capture. I know I was part of a presentation at TRB for some universities are actually doing a lot of research in here is actually, some of the void space in the concrete, looking at like biochar and other things to actually capture the the carbon from the air, and while making sure that it maintains all the structural properties over time. So that's actually an emerging market. I know there's a lot of patents out there right now, and there's a couple companies that actually just formed, trying to take advantage of this. So that's a growing market, but something I think we're going to hear about a lot more, in the future. And then with concrete, the other main, building material is steel. So there's kind of the typical steel making process, which you'll see on the left, where they uses a basic oxygen furnace. So this is, high, lots of fuel, lots of lots of raw materials, to make steel. And that was what they used to make steel back in, like, the turn of the century. You'll see all those, in Pittsburgh and other places, all those like the old time manufacturing and steel mill. A lot of that was, through this process. And then when it was done, wasn't recycled because of, a lot of the properties of steel, but just also how valuable it is and how the amount that it can be recycled. There's this newer way of doing it, where it's you're recycling the steel, and also using an electric arc furnace in the recycling process to, remanufacture the steel. And that's, you can see from the numbers on the bottom there, the carbon intensity of that, 2.3 to zero point 0.6. I mean, that's like a 25% reduction right there by using the electric arc furnace and also the recycled steel. So, one of the sources there was a steel recycle, Nucor, which is probably the largest steel like recycler in America. So obviously they're biased to it, but there is really a benefit also with using recycled steel, and that obviously results in a much lower carbon footprint. So this is just some, other information from Nucor, and just a little bit of the ways that they're looking at, again, their process, so they can lower their carbon intensity right now. So with concrete and steel, you can see all the efforts that are going on right now to lower the carbon intensity of these materials. So this is also going on with a lot of other products that are out there too. Asphalt, glass. So all of this research right now is going into that. And the number one thing is the recycling. Goes back all the way to kind of environmental 101, right? Recycling of materials, using them again. So a lot of the ways that, manufacturers are looking at reducing the carbon footprint is also how construction debris is managed and how it can be recycled in the future. So you can see some of the things that, at least Nucor in this scenario is working towards lowering their carbon intensity. So they feel like they can get down to like 0.12, which right now they're at, 0.46. So they feel like they can get to even 25% of the 25% that they're at right now. It just shows you some of the stuff that the manufacturers are doing, but there's also like policies. So a lot of, in this area, a lot of this is driven by the market, and the market's driven by policies that are out there. And it's, the federal, state, and local level. There are a lot of policies that are sort of starting to drive this. And also, there's private companies too, the Amazons of the world and the Googles who are really and Microsofts who are really, you know, very progressive in what they're doing on the sustainability side. You know, they're doing this and looking at this for their projects as well. I'm just going to talk a little bit about. So I guess again, this is one of the first things that kind of caught my attention on this subject is the New York State Executive Order 22. So this applies to New York State agencies and contracts over $1 million that have these thresholds of materials. So right now, what they're looking at is this executive order isn't necessarily dictating a certain embodied carbon in the projects. They're looking to, if you're meeting these thresholds, what you have to do is understand, determine what the embodied carbon of your project is, and then report out on these materials. And the good thing is they're developing this, they're going to be developing this database of all these items that are going into projects in New York State now. So what you can understand is you can choose the lower carbon materials going forward. So this kind of reporting and this database that's out there is really going to help, I think, expand the the knowledge in this area, quite a bit going forward. So right now, this isn't dictating, a specific number or amount of embodied carbon. But if you meet the thresholds, you have to get the environmental declarations of the projects you're doing, calculate your embodied carbon, and make sure you're reporting on that. And that's going to be done on a annual basis, but like project by project by the agencies. And the first report is due, I believe, this June or July. So we'll be getting these results, and then right now it's a reporting function, but it'd be interesting to see how these go down over time. So that's New York State Executive Order number 22. Then on the federal level, as part of the Inflation Reduction Act, so that act that included a lot of different environmental requirements and legislation, and also, I guess, relative to our discussion, a lot of requirements for clean buildings and climate protection. Um, Again, about the federal building portfolio, trying to go to net zero by 2045, um, net zero emissions procurement by 2050, and even more than just a requirement, they put making a $2 billion investment in these low carbon, lower, I don't like to hate to use the word green, but those kind of construction materials and products that have lower levels of embodied carbon. So what actually is very interesting about this is EPA went through all the different building material, a big study on all the different building materials that are out there, and they made this interim determination of what would be considered materials that have lower levels of the embodied carbon, and that actually came out in December of 2022. So those studies are out for all these different materials. So right there on the federal level, which they're driving this market now for the lower levels of lower embodied carbon materials. This is the same thing that actually happened for recycled paper, where you can't even buy other types of paper anymore, because once the federal government made that a requirement for purchasing, it kind of just filtered through the industry and everyone had to do it. So they sort of set the market there. So they're doing the same exact thing here on the lower the construction materials and products. The other one I wanted to talk about too is the Port Authority in New York, New Jersey. They have a clean construction program, and there's a couple different elements to their clean construction program. They start with a long time ago, Port Authority developed their own sustainable guidelines for buildings and infrastructure, and these actually predated LEED and the Envision certification, and just really set like how sustainable design for Port Authority buildings and infrastructure worked. Um, so that was, initial one that they came out with, probably, 15 years ago. But what they're actually also doing, is, since they've come up with them, they've revised that and have, different construction requirements, which MT also does too, for, lower emission vehicles. Certain amount of construction waste has to be recycled, and they're also having a low carbon concrete mixes. So they're actually specifying that. Again, they have requirements for the environmental product declarations for their large projects. They also have, I think, two kind of, I think, innovative programs. They they're not only telling people to recycle certain parts of their construction waste, but what they actually do is they're having like a matching and reuse database that they maintain. So if you have a certain construction project, you can see different like vendors and uses in the area. So it helps you find, different ways for the materials to be recycled versus just like having it sitting on site for a while. They're also working with, they have a low concrete research program too. So they're working on, you know, not only evaluating the mixes which they historically use, but also, doing research into lower carbon mixes and things that would hold up over time. So that's, it's like a consortium of, research by Rutgers, Princeton, and also NJIT. We got to find a way to get Stevens on there, I think, but that's what's going on there. This just gives you again a figure here related to their clean construction program. So you can see the different elements. I think we talked about all of these already about different elements going into their clean construction and how they're trying to lower this carbon footprint in their infrastructure projects. So, last but not least, the other thing I did also want to talk about too is the ASCE Sustainable Infrastructure Guidelines. So one of the interesting, I think, differences between this and some of the other, kind of requirements that I talked about is that ASC, before they came out with these sustainable infrastructure guidelines, they developed the Envision rating system. And the Envision rating system is a certification that you can get for your projects that allows you to go through the whole design process and figure out sustainable kind of measures for all different elements of the project. So what the ASC standards is took that and kind of built upon that with all the different concepts that we were talking about today with embodied carbon, doing life cycle assessments, resiliency. And also the one thing that the ASCE includes also is the triple bottom line or sustainable return on investment. And that concept is, similar to your typical return on investment, but talks about all the looks at the environmental benefits of a project too. And especially when you're dealing with public agencies, you know, a bus depot, for instance, for MTA isn't a money-making, project. It is a societal benefit. So if you're deciding between different options on a project like that, the overall sustainable return on investment is at times a good way of looking at something to determine, this additional feature of the project is that really going to bring a benefit. Um, so those are some of the little differences and nuances of the ASC Sustainable Infrastructure Guidelines and how that is slightly different than than the different regulations and standards that we're talking about. Okay, so just some of these this kind of summarize. This is from builds upon, the UN, the UN's research and kind of, work in the buildings and infrastructure space, and what they're saying are, general principles. Again, right up front, avoiding waste, build with less, and improve. Like, think about the project with the end in mind. Build a project out of materials that can be recycled a lot easier. So that's one of the right away important concepts. They're talking about a shift to bio-based building materials like timber and wood and bamboo, and obviously that's not practical on, a lot of the stuff that building in, you know, big infrastructure projects in New York City, for instance. But, on residential where you can shift to that, it's important to do that. Um, Improve like the non-renewable building materials that are used, concretes and steel, is working to really lower the embodied carbon or carbon footprint of those materials as much as possible. And then also something that they didn't talk about, but I added to, is really designed to the highest potential design standards. Lead and Vision are just one of many design platforms or rating systems that are out there. But, instead of just doing the minimum, look at ways of that should be your baseline, and look at ways you can improve, because these investments will not only lower your operational costs, but also the environmental footprint of the infrastructure over time. And again, this is just a good, I think, summary of some of those like very specific reduction strategies on your project. Doing this embedded carbon analysis up front, finding what the numbers are, and then procure materials that have the lowest, that meet your requirements but have the lowest footprint possible. And as far as transportation is concerned, looking at methods like rail and barge, which are less carbon intensive than trucking everything. There could be a lot of different benefits to this, and it should be something that should be considered on a project. I know sometimes we look at projects and it's not just bringing materials to site, but disposal. Can you use rail or barge to do that? On a construction site, not only using, renewable diesel equipment or bio-based diesel equipment, but maybe even electrifying it where possible. Um, there's benefits on the carbon front, but there's also, noise, there's air quality. So, we've worked on projects where maybe the air quality is an issue. Looking at electrifying the construction of the project really can go a long way to reducing those impacts. And again, last but not least, looking at your materials, how you can reuse, how you can recycle everything, using materials with a high recyclable content. That goes a long way to lowering, again, the impact of infrastructure, which is what we're trying to do here. And there's just some other guidelines and for you, and there's a lot of others out there. These are just some of the ones that I used in the development of the presentation. So thank you for your time. I know we have some questions. I mean, I'm done a little early here, but gives us a
Yeah.
little bit more time to talk.
Yep, that's good.